So you guys, example 7, we are reversing what we did in example 6. This time I'm giving you a bunch of logs and we're going to express it as a single log and we're going to simplify. So we're going to be solving. So this one's a little bit more involved. Okay, now before we write it as a single log, what we have to do first, we are going to be reversing what we did last time. So the last thing we did last time was apply the power rule. So guess what? We're going to apply the power rule first this time. Okay, so I'm going to set up my logs real quickly. So I have my parenthesis plus log parenthesis minus log parenthesis. Okay, and all these are logs with base 2, so I'm going to fill in my bases. Alright, and now we have to decide if we need to use the power rule or not. So on my first one, it's just a simple 8, nothing's in front of my log, so I'm going to leave it as log base 2 of 8. Alright, now my next log, we have a number in front. So now we'll be shifting that bad boy to the exponent spot. Okay, so this will now be 2 squared. 2 squared. Okay, and then my final log doesn't have a number in front, so it's already good to go. Okay, so now that we've applied the power property, now we are going to express this bad boy as a single log, so only one log. So I'm going to set it up and explain how I'm setting it up. Alright, all these have base 2, so guess what? My single log will also have a base 2. Okay, and we're going to work our way from left to right. Okay, the first 2 logs I see are added together, so that means we're going to be using the product property. So we will be multiplying the values inside the log. So this will be 8 times 2 squared. Okay, and then if you see here, the last 2 logs are separated with subtraction, which now means we're going to be dealing with the quotient rule, and when we see subtraction, the first parts go in the numerator and whatever comes after the subtraction symbol goes in the denominator. So my 4 is going to go in the denominator. Alright, so before we start solving the log, I'm going to simplify this bad boy on down. So we have log base 2. Alright, let's see here. 2 squared is 4. And 4 times 8 is 32. So my numerator is secretly just a 32. Okay, which I'm going to write this in green so you guys can see it a little better. Alright, my denominator is just a 4. Alright, and we can continue to simplify that. So this will be log base 2 of 32 divided by 4 is simply just an 8. So log base 2 of 8. Alright, now that we simplify down our fraction, we can solve this logarithm right here. So we're going to move on to solving. Okay, I'm just going to write it all in one color just to make things a little easier. Alright, and remember when we start solving, we set this equal to a number, which I'm just going to set it equal to x. Okay? And then we have to convert this into an exponential. So the base of my logarithm is the base of my exponential, which the base, you guessed it, is a 2. You guys are so smart. Alright, and then remember, these two are going to trade places. So my x is going to hop to the side with the 2, and it'll be the exponent. And my 8 is going to hop on the other side of the equal sign. Okay, or if you like the roundabout way, remember you can simply do 2 to the x power equals 8. Either way. Alright, so now our goal is to get the same base on both sides because once we do that, we can just drop our exponents down. Okay, which I'm going to bring this up here. So I'm running out of space. Okay, so I need to think of a base that not only goes into 2 and 8, but also I could raise to a power to get 2 or 8. Okay, which the only thing that goes into 2 and 8 that's not 1 is 2, which I can raise to a power to get 8. So I think 2 is going to be the way to go. Okay, so we have 2 to the x power equals, okay, I need to think of 2 to what power gives me 8. So let's see here. 2 times 2 is 4 times 2 is 8. So that would be 2 to the 3rd power. And holy hot dog, you guys, I now have the same base on both sides. we have a 2 on both sides. So guess what? For my final answer, I can drop down those exponents and set x equal to 3. So that's my final answer. All that just secretly equals 3. So cool, so cool. Alright, so part B is pretty much the same as part A. So if you'd like to try part B on your own, go ahead and pause the video and fast forward to the end and see if you get the right answer. So remember, the first step we always do is to use the power rule and bring any number in front of our logs to the exponent. Okay, so I'm just going to rearrange these real quickly. Or not rearrange, but set it up, sorry. So you have log of something plus log of something minus log of something. Alright, let's see what happens. So, this first one, I have a number in front of my log. So using the power rule, we're going to move that to its exponent spot. So this will be 5 to the second power. Okay, this next one, I can just leave alone. There's nothing in front of the log. There's no power property to use. So, I'm just going to leave it as 25. And this last one has a 3 in the front. So, using the power rule, we're going to move that bad boy up to the exponent. So this will be 5 to the third power. Okay, so now that the power property has been used, now I can write this bad boy as a single logarithm. So I'm going to set it up. Okay, so in this problem, which I forgot my base, holy hot dog, Miss Long, our base from the original was 5, so I should have included it in this step. Sorry guys, the demon cats are totally winning right now. Okay, so since my base is 5, my base of my single log will also be 5. Okay, we work our way from left to right. The first 2 logs are adding, so that means we're going to use the product property, sorry guys. We're going to use the product property, which means we multiply these 2 together. So we have 5 squared times 25. Okay, and then we look at our last 2 logs. They are separated with a subtraction symbol. So this means we're using the quotient property now. So we'll be moving this bad boy to the denominator. Remember, the part after the subtraction symbol is what comes in, or what goes into the denominator of your fraction. Okay, so we're going to simplify this down real quickly because we got lots of 5 squareds. Okay. Okay, so let's simplify down this numerator. So 5 squared, which I'm going to write my answer in green so you guys can see it. 5 squared is 25, and 25 times 25 is 625. Alright, and it's all over 5 to the third. So let's see what 5 to the third is. 5 times 5 is 25, and 25 times 5 is 125. Okay, so let's see what this simplifies to be. Okay, so we're going to be dividing 625 by 125, which that simplifies to be just 5. Okay, so now we have to figure out what this log equals. So let's solve for the log, which I'll just write in one color to make things a little easier. Okay, which remember we start by setting this equal to anything, which I'll just make it an x. Alright guys, so we got to convert this bad boy into an exponential. So the base of my exponential is the base of my log, which is a 5. And then remember, these 2 are going to trade spots. Okay, so my x is going to hop to the exponent of the 5. Alright, and this 5 is going to hop to the other side of my equal sign. Okay, which look you guys, they already have the same base. Holy hot dog, they already have base 5. Okay, and the exponent, remember if you don't see an exponent, it's secretly a 1. So now that we have the same base on both sides, we can drop down our exponents and set those bad boys equal to each other. So x is simply 1. Incredible. Incredible. Okay, now you might have already known what the answer is at this step, so we'll talk about how you could have known that. Okay, if we have log base 5 of 5, remember if you ever see the repetition of the base and the number in the log, okay, that's using one of our identity rules, which states anytime you have a base of the log, it's the same thing as a number in the log, it simply equals 1. So technically from this step, we should have already known that that is 1. So if you caught it early on, okay, you could have already said x is equal to 1. You didn't have to go through all those other steps. Okay, so that is it with example 7.